Hello friends, welcome to Aromaticity video part 1. In this question, which had appeared in CSIR NET exam December 2011, among A, B and C compound, which are the aromatic ones. Now for the aromatic things that we should know, it should be a cyclic compound. Definitely it should be a cyclic moiety. The next thing that it should be there, it should be conjugated double bonds. The next thing, it should be a planar molecule, very important. If the planarity is not there, then it will not be aromatic, and it must contain 4n plus 2 pi electrons, very important, another rule. Okay, n can be 0, 1, 2, 3, like that number. So cyclic, conjugated, planar, 4n plus 2. Any one of these missing, it will not be aromatic. Any one. So let's check for this part. Well, I'll start with C. Each bond, this bond, it consists of 2 electrons. 2 electrons. That we should know. 2 electrons, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 electrons. In this case, for C, we are having 10 electrons. We are having 4n plus 2. If I substitute n with 2, so 4 times 2 plus 2 equals to 10. So that means this number is matching. So this rule is satisfied. Now regarding planarity, this is a planar molecule, the naphthalene one. This is planar molecule, yes. Why it is planar? Because this bonds holds in the planar structure. Regarding it is conjugated, we have to check whether there is any sp3 hybridized carbon. sp3 hybridized carbon is there, that means it will not be conjugated. Here double bond is there, sp2. Here again sp2. Hybridization video you can check if you don't know how to check the hybridization of the particular carbon. So all the carbons are sp2 hybridized, so it will be conjugated, yes. Any sp3 hybridized carbon, it is not conjugated. Just remember, sp3 hybridized carbon, it will not be conjugated. Regarding cyclic, yes, it's a cyclic structure. So all 4 conditions are matching. So this will be aromatic. So C is aromatic. Now what about the B part? B part again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we are having, for B, we are having 10 electrons. Again 10 electron, if you check this rule, it is having 10 electrons. So B, for B part, this is fine. Is it planar? This oxygen molecule will fold it into the planar structure. Yes, it will be planar. Is it conjugated? Check for any sp3 hybridized carbon. It is not there. So conjugation is there. Yes. Cyclic structure. It's a cyclic structure. Yes. So B is also aromatic. Now what about A? The first thing is it a cyclic structure? Yes. So for A part, I will write it here. So it's a cyclic structure, yes. What about conjugation? Any sp3 hybridized carbon? No. This is sp2, all sp2. It is conjugated, yes. It is conjugated. Now regarding its planarity. Now planarity, we have to remember, there is no bond holding them in the planar structure. There is a hydrogen here and there is a hydrogen here. What these 2 hydrogen will do, these hydrogen will repel and it will not be in the planar structure. Since planarity is not maintained, this will not be aromatic. So only B and C, they are aromatic. This is aromatic, this is aromatic. This is not aromatic because of this hydrogen. It disturbs the planarity and it is not aromatic. In this question, the compound that is anti-aromatic is, we are having the following compounds. We have to check which is the anti-aromatic one. For anti-aromatic, what is important? It should be a planar structure. It should be cyclic. Cyclization should be the cyclic structure. It should have the delocalized conjugation should be there. And the last one is the 4n pi electron. This is very important, 4n pi electron. For aromatic it was 4n plus 2 pi electron, but in this case it is only 4n pi electron. And remember, anti-aromatic compound, they are highly unstable. Rarely you will get it in the nature as free compound. Now among these four, let's take this example first. Is it planar? Yes, it is 5-membered ring. It will be planar, smaller molecules. So planarity is there. Regarding cyclic structure, it is a cyclic structure. Conjugation, now let's check conjugation. What is the hybridization here? sp2 hybridized boron carbon, boron atom. So it is sp2 hybridization. What is the importance of sp2 hybridization? This two bond should be delocalized. It should be moving around in the cyclic structure. It is very important that the double bond is moving in the cyclic structure, which is held by the sp2 hybridized carbon when no charge is there. So conjugation is there. Now regarding 4n pi electron, that we need to check. 1 electron, 2, 3, 4. So 4 electrons are present in the ring. So regarding 4n pi electron, if you substitute n with 1, so this will also give 4, and it is satisfying all of these conditions. And I am substituting n with 1. So 1, 4 times 1, it is 4. So 4 electron, it is matching. All conditions, since it is matching, it will be anti-aromatic, highly unstable molecule. What about the other three? In this case, if you are carefully observing, it is not planar structure. Planarity is not there, it will not be anti-aromatic. Now regarding this carbon, it is sp3. Hybridization, you can check my video on hybridization. sp3 hybridized, the cyclization, the delocalization of these electrons are not possible. They will not move around the ring, and it will not be anti-aromatic. Regarding this one, it is having planar structure, yes. Cyclic structure, yes. Conjugation, it can move about if the charge is there. What about 4n pi electron? That condition is not satisfying. We can put the value for n as 0, 1, 2, 3. If you put 0 here, 4 times 0 is 0. If you put 1 here, 4 times 1 is 4. But how many electrons are here? 1, 2. Only 2 electrons. So 4n pi electron, it is not matching. So this is also not anti-aromatic. So what is our answer? That is this part. 1 is the answer. This question was from CSIR Net December 2014 for 4 marks. Simple one. In the upcoming videos, I will take more of aromaticity examples.